Hello everyone, this is Miss Kaylee here with a lesson over Earth's rotation and revolution around the sun. This lesson is for all you great 8th graders out there. A note for teachers, the standards for this lesson are at the end of the video. Here is our student learning objective. By the end of this lesson, you will know what rotation is, what Earth's revolution around the sun looks like, what Earth's axis is, and how the Earth's rotation and revolution affect the seasons and the day and night cycle. Here is a list of the materials you will need for this lesson: a computer, internet access, paper, pen or pencil, markers, or colored pencils. The technology we will be using in this lesson is weather.com, Google Earth, Google Docs, Solar System Scope, and quizzes. In a moment, I'll ask you to pause this video and write down on a sheet of paper answers to these questions. What season are you currently experiencing in your area right now? And do you think everyone in the world is experiencing the same season as you? Why or why not? Pause this video now to answer these questions. With all that in mind, you will now be creating an observation table that includes coordinates, city, country, time, hemisphere, warmest month, coolest month, and average temperature in May. It will be comparing 7 different cities around the world. Pause the video, and once complete, return for step 2. Welcome back. Now you are going to go to the Google Earth link here. This link is also in the description of the video below for easier access. You will click on the Launch Earth button displayed right here. If there is a tutorial, you can skip it using the X at the top right-hand corner over here. Now, you'll go ahead and click on the magnifying glass. Using the coordinates provided, you will type them into the box and click the search button. For our purposes, I'll be using these coordinates. As you can see, we found a pretty interesting city. You will need to zoom out to see what city you have found. The one I found here is Fort Worth, Texas. This is not one of the coordinates listed. You will need to do this for all 6 coordinates. Once you have completed that, you will click the I'm feeling lucky button here, which also looks like a dice icon. This will take you to some unknown location around the world. Depending on where it takes you, you will have to find a city nearby and add this to your table as well. You will have a total of 7 cities. Pause this video to create your table. Now that your chart is complete, you will go to the weather.com app, also listed in the video's description below. You'll go to the monthly tab right here. And up here where it says search city or zip code, this is where you'll enter in the cities that you found. For me, I have found Fort Worth. You'll see the current time of the city there. As you scroll down, you'll also be able to see the warmest month and the coolest month. For this exercise, our warmest month is in July and our coolest month is in January. You'll also be able to find the historical monthly average here on the right for May, and for this city, it's 84 degrees. You will use this tool to answer most of your questions. You will use Google Earth to answer country, city, and hemisphere. Pause this video to complete this activity and make sure to have lots of fun. I am sure you are beginning to see a trend with cities in the same hemisphere, so let's dive a little deeper. First, I will need to explain what rotation and revolution is. Rotation is Earth's turning or spinning on an axis. An axis is an imaginary line that runs through the Earth. You can see this shown right here. Earth is also tilted on its axis at 23.5 degrees. This tilt always faces north. Think of the rotation as a spinning chair or a perfectly balanced basketball. As the Earth rotates, it creates our day and night cycles. It also takes a full 24 hours for the Earth to rotate. Earth's revolution, however, is Earth's orbit or trip around the Sun. An orbit is a path taken around an object. Earth is not the only thing that revolves. Our moon is a great example of revolution as well. It orbits the Earth similar to how Earth orbits the Sun. Earth's revolution around the Sun takes 365 days or 1 year, while the moon has about a 28-day revolution cycle. Earth's revolution is also responsible for the seasons. Summer months have longer days and shorter nights, while winter has shorter days and longer nights. Spring and fall typically have equal days and nights. Now, for any of this to make sense, we need to talk about hemispheres. Hemispheres divide the Earth into two equal parts from the equator: the northern hemisphere and the southern hemisphere. The equator gets equal amounts of sun all year long based on its very central location on the Earth. Each one of these hemispheres experiences seasons differently. But how does this happen? Because of Earth's tilt, it allows different parts of Earth to be closer or farther away from the sun. Here, let's look at this. When we look at this diagram, we have a better picture of how Earth revolves. As you can see, the 23.5-degree tilt of the Earth's axis always points in a northerly direction. This allows for seasons to occur in different hemispheres. When the northern hemisphere is pointing towards the sun, it is in summertime, while when the southern hemisphere is farther from the sun, it's wintertime there. This would explain summer having more daylight hours and winter having less. It is all about the right amount of exposure to the sun. We are going to watch a video that will sum up everything we've just gone over. On your observation paper, if you have room or another piece of paper, please answer the questions I asked from the video.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night. Every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now, hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the sun. Now here's the thing.
So now I'd like you to pause this video and on your sheet of paper, answer this. What is the difference between revolution and rotation? Remember, rotation is when Earth spins, creating night and day. Think about a basketball being balanced on someone's finger as it rotates around. While when we think of revolution, it's actually where the Earth rotates around the sun. The sun is the main focus as the Earth slowly moves its way around. So let's continue our video.
As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted, just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. Winter. In between, it's spring or autumn.
Pause the video and answer these questions. What is the significance of Earth's axis, and how are the seasons affected by it? So let's remember, Earth's axis right here allows different parts of the sun to hit the Earth at certain times throughout the year. This process also creates our seasons. When the northern hemisphere, right here, is closer to the sun, it's in summertime, and vice versa. When the southern hemisphere is farther away from the sun, it is wintertime here. When you look at your chart, you're able to see that some of our cities are in our northern hemisphere. And when you start looking at what temperature it is in May, you can see that it's beginning to really warm up in this area because we're coming into summer. Right now, everybody's kind of in a spring and fall area. But because our northern hemisphere is starting to slowly face the sun, we're actually able to become more warm. When we looked at our southern hemisphere cities like Australia, we were able to see that from now until May, it will actually become cooler. And some of its coolest time will be in June and July. So what does this look like right now? Well, let's go find out. Here we're using our solar system scope. We're able to see our solar system here. And if we zoom in, there's our sun and our Earth. This is April 10th. And we can see that if we zoom out just a little, our Earth is in a spring and fall cycle. As we watch the Earth rotate, we will notice the southern and northern hemispheres are about equal distance from the sun. But as time goes on, let's see what happens. As we can see, by the time June arrives, the northern hemisphere is tilted closer to the sun, which makes it summertime in these areas. As we continue to watch, we can see that starting in August, we are beginning a fall/spring-like cycle. If you would like to explore more after this lesson, the link to the site will be in the description of the video below. You can explore the Earth, Sun, Moon, and other planets in our universe. Let's jump back and see what activity we have next. We have now seen how the Earth's axis affects our seasons in real time. But what would happen if the Earth was not tilted? For this next activity, I would like you to draw me a picture or create a Google Doc that shows me what this would look like. Please feel free to use as little or as much color as you would like. I would also like for you to explain how this lack of an axis or tilt would affect the seasons. Pause this video, and when you're finished, please take a picture of your observation table, answers to the question from the video, and your pictures, and turn it into Canvas. As our final part of the lesson, I would like you to jump to joinmyquiz.com and enter the code 274508 to complete a quiz. This link is also down below in the description box. I hope you all have learned a lot and have had some fun. I'll see you guys next time. Special note for teachers. Here are the TEKS, NCSS standards, CCRS, and ELPS. Thank you for watching.